Swayam Prabha. Digital India. Educated India.
Hello everyone. Welcome to the NPTEL course on Remote Sensing and GIS for Rural Development. This is week 8, lecture 1. I also have to share a very important aspect regarding this course. In last week, I was in UP for a groundwater conference, and I was very happy to see a student who came up to me and said this course has been very helpful for her preparation and to address rural development in a different lens. I thank for the feedback and hope to continue to give information and knowledge about remote sensing for rural development through these lectures. Let us continue for today's lecture. What we saw in the previous lecture was Introduction to Google Earth Pro and DEM. We touched basics on Google Earth Pro and then DEM. Since this is the week 8 first lecture, I thought I will give an overview of what has been discussed and then lead into today's topic, which is very important for rural development. So in week 7, we had covered the Google Earth Pro intro. Google Earth Pro is a data archive. It's not a data source, but a data archive where multiple satellite and observation data is hosted. It helps researchers to identify data, download data, and also download analytics, which is very important for land use, land cover classification, and rural development attributes. We also looked into extraction of ground control points from Google Earth Pro. Initially, we had extracted them using paper maps, but then we also looked at how to extract from Google Earth Pro. We also looked into plugins. There are multiple plugins, but we focus only on one plugin, which is PicMap. These are very important plugins and data tools for rural development lectures. Please note that you may not find tutorials and reading information about these plugins now and then because they keep updating. And sometimes the plugins are stopped because it has multiple data sources and it works on multiple themes. In this NPTEL course, we will not be able to cover all the data and plugins, but however, I'm going to give you introduction on the most important ones. And that is what the plugins that we discussed in the previous lecture. Then we also discussed about the digital elevation model, DEMs. In some aspects, it is also called terrain models, digital TEMs or digital terrain models. We have given some intro and sources where you can download them. And then the DEM for an area was extracted using a mask. A hands-on tutorial was given to extract this data using a mask. In week 8, which is the current week session, we'll be looking at land use, land cover, which is shortened as LULC, very commonly called. And then we have LULC change. So how does land use and land cover attribute to rural development? And we also have how does LULC change? Why it is important for rural development? We'll give an intro so that when you download this data and use this data, you know how to use it for your rural development scenarios. We will also look into keyly specific water and land management, because when you talk about the land use and land cover, these are the two main features that get disturbed: water bodies, water use, and land cover. So land management is a very important aspect of land cover. So we will discuss that. So once we clarify how LULC is very, very important, then we dig into data issues and proxy data that can help LULC. So first we'll discuss about data issues, why and how there is very less data about land use and land cover. And then we will identify some proxy data that can be used for land use, land cover estimations, especially remote sensing, because this course is about remote sensing. And then we will get into data issues and proxy for LULC, which is the remote sensing sources, key sources, out of which one is Bhuvan LULC maps, and there is also NASA-based USGS LULC maps. As I say, these get really updated fast. For example, when I was doing my PhD, I used to download this data, mark it, and then classify into different land use and land cover. Whereas now, a click of a button, you'll get it done. In those times, it was a master's thesis, 1 year of hard work to make one map. But now it takes 2 seconds. Okay, so thanks to technology and science and development, it is very easily available. I will go through the ones where it is very, very quickly available. But as the science and development happens, the ground reality is very different. How it applies to the ground is different. And that is where I would like to tell you that these technologies are good. However, if it is not tested and applied to the ground, it is of less value. So I hope most of you would use these lectures and try to use them for your studies, research, interest, life aims, goals for rural regions. We'll also discuss on-the-fly remote sensing for LULC, as I said, USGS, and also Google Earth Pro. These two aspects we will cover in this lecture. First, let me introduce the hydrological cycle to show why the land use land cover is very important. As we discussed earlier, the entire rural system or life on Earth is focused primarily on water and water availability. Water drives life form across the planets. And that is why all these rovers and missions across the space is looking for water. There's no other material, no other resource they are looking at first. It is water. Once you have water, there are indications of life. So coming back, the hydrological cycle is driven by the sun and the availability of water on Earth. The hydrological cycle includes water converting from liquid to gas to solid phase and then back to liquid. And for today's lecture or the week 8 series, what is more important is, get my pointer. What is more important is these processes have been discussed slightly or in depth in other NPTEL courses. In this current course, we have discussed very small aspects of evapotranspiration, rainfall, etc. But this the geological unit, plays a vital role. For example, if the land is managed properly, then water can go in, infiltrate and go to the groundwater, which is a storage. It's like a bank account where you have money coming in. So the water has to pass through the soil. And if you manage the soil well, water passes through and then gets stored in the groundwater aquifer for you to use in a later period. It is not a rigid storage, it is a leaky storage. However, water is present. If the land cover is not maintained well or it is used for different purposes, let us say a barren land which is not maintained well, water hits the barren land and goes as runoff. Same, if you have a concrete jungle where like Singapore, for example, you have so much of concrete, which was initially forest and agricultural land. Now everything is concrete, right? So once concrete, what happens is water hits and then goes to the drain and then becomes runoff. If there's no drain, like in Mumbai, you see floods. So the management of land and the use of land is very important for preserving water and soil nutrients. For example, if you're putting a lot of cement on top of the land, the soil underneath doesn't get nutrients. There is a lot of nutrient arresting mechanisms, biophysical mechanisms that help the soil to sequester nutrients. And if it is not exposed to sunlight, air, atmosphere, it will not be as nutrient rich as possible. In other standings, if you have a forested land, you will see that the climate is much buffered. You don't see too hot or too cold. Same way, wind is buffered, and you have a lot of life form, life activity with forest cover. So these are the aspects that we will be covering in this 8th week. I hope you understand the importance of land, that it helps to provide a base where plants can grow, plants can root, and then provide nutrients, which is important for soil and eventually lead to rural livelihoods, thereby leading to rural development. However, roads are important. So roads have to be mapped into the land use land cover. Houses are important. It has to be mapped into the land use land cover. And that is why keeping a very updated land use land cover map is very important. We will cover also in the next week lecture the mapathon and show how people can take part in the mapathon activities for updating the land use land cover. So moving on, since now we know what is the hydrological cycle and how the land and land cover and land use play a vital role in getting water, soil, nutrients to the rural environment. Let us get into details of land use land cover. First, let's look at the first part, which is land cover. Land cover refers to, as per the USGS, the vegetation and artificial structures that are on top of the land and covering the land. So if you have a land, what is on top, what type of vegetation and artificial structures? So for example, you have a big garden in IIT Bombay, we have big gardens, and around that there is administration buildings, right? So you have gardens, administration buildings. So these are on top of the land. Examples of land cover include trees, grass, crops, wetlands, water, buildings, and pavements. So land cover is something that covers the land. It could be artificial, it could be natural also. Okay. So for agriculture, where will this be, or rural development, where will this be very important? Yes, crops are very important. Sustainable agriculture requires preserving the forest, so agroforestry is important. Water, wetlands are very important to preserve the soil nutrients and to mitigate against climate change impacts, like the Sundarbans are playing a key vital role in reducing the sea level rise in Bangladesh. And buildings and pavements, as we talk about bringing in mechanized agriculture, bringing in industrialization, small scale at least, in livelihoods of rural population, there is a need for pavements, which is roads, kind of roads in rural networks, and some small scale buildings. So while land cover is very important, scientists also understand that land cover along with land use makes sense. Just as land cover doesn't make sense, but what is the land used for makes sense. So let's first dive into more definitions of land cover. Land cover is the observed biophysical cover on the Earth's surface as per FAO. The Food Agriculture Organization defines it as the land cover, which includes the biophysical cover on the Earth's surface, is given as land cover. Physical cover is good, but also bio is very important. Physical could be soil, water, wetlands, etc. But what is the biology involved in it? Like for example, the forest has a biological impact on the soil and the land that it is surrounding. Please think it as a rural entities. If you're in a rural setting, what would you like? You would like the soil to be highly nutritious. You like water resource to be there for farming. You would like quickly for the produce to come out of the farms into the storage and back to the market. Again, a rural livelihood will grow as long as the demand is met through a supply chain network. The supply chain requires good roads, efficient transportation, for which there is a land cover which is going to be put. Consequently, areas with bare rock or bare soil or land, not land cover, because there's nothing covering it. It's just bare minimum. So think about land cover as what you wear. The basic skin is just pure land. There's only bare soil, bare rock. There's nothing growing on it. So you cannot say that is land cover. But when you're putting extra layers, like jackets, like shirts, like t-shirts, then each one of it becomes a land cover. In global terms, in earth terms, let's say the entire land was fully barren, and then slowly the forest came up, slowly the water bodies came up into one pool. Maybe first it was full of oceans, then we had pockets of water which became lakes, ponds, rivers, streams, springs, etc. And these are land cover. There are different classifications that exist, which is a concern. I'll tell you why when we dive into the land cover aspects. FAO gives one example of land classification, but there are multiple different classification techniques. The basic classification of land is land cover classification is by physical appearance. You go to a place, you look at how the land cover is there, what type of land cover is there, and then you mark it. Let's say you first take a land and then you grid it. Okay, same as we did for our rasters, etc. So you have the land, you divide it into grids. Okay, let's say we have 5 columns and 3 rows. So you go to each grid and then look at the physical appearance. It could be agroclimatic, agroecological classification. Agroclimate is the climate of the region, that grid, and what is the crop that is growing. Agroecological has more ecological weightage. Technical attributes like soil profile, soil texture, agroclimatic conditions are noted. So these are part of the classification technique. And then land use classification is what it is being used for. Let's come back to land use later. But land cover is basically on the physical appearance. You may do a survey and then look at what is the land cover. Look at this map, which we have already shared. This is an older version, 2004. I'll be showing a new version in the hands-on exercise. You could see that this is the land cover map of the world, taken by the European Space Agency, mixing a lot of satellite data. And you could see like how many legends, how many classifications are there. In this legend, you have at least 20-30 classifications of the land cover. So cultivated area, post-flooding, sparse, mosaic, closed forest, needle-leaved green forest, artificial surfaces and associated areas, water bodies, all these are land cover. And how does that help? It helps because now you can identify where the key land covers are present. So maybe, for example, the evergreen forests are present. The dark green is broadleaf evergreen, semi-deciduous. So all these are evergreen forests. In India, you have post-flooding irrigated croplands. So the Ganges Basin is one of the largest irrigated croplands in the world, and that is being captured by satellites. So now let's come to the second half of the name LULC. LC, which is being already discussed land cover. We first discussed land cover. Now we are going to discuss land use, LU. And what is its role in rural development? So land use is defined as a series of operations on land carried out by us, the humans. with the intention to obtain products, benefits through the land resources. So you see land as a commodity, you convert it to a profit by your applications of technology, manual applications, etc., and you harvest something out or you gain something out using the land, and that is the land use. So there could be a product, but there is a use for the product. If you buy a car and you just keep it, it's just a car. But if you buy the car and use it for transportation, then the car's use is transportation to go up and down. You would see a lot of people just buy the car and keep it, which is of no use, just to show off their money. But use is actual use that the humans use it. And so they put petrol and work. So same thing, land is there. It could be a forest cover, it could be a cropland, but if there is human interference and there is a profit that is being generated through the land, then it is called land use. Refers to the purpose the land serves. There are a lot of examples, including agriculture, wildlife habitat, recreation, etc., etc. Wildlife habitat, not the natural forest, but wildlife habitat is like mostly your resorts and stuff where you have enclosures and then you put animals in zoos, etc. So how is this important for rural development? Normally, I would stop here in a live class and ask the students to think and give answers. Given it's a virtual scene, I'm just going to say that it is very important for rural development as it gives the land available for the rural development activities and options. Let's say you have land. You want to start a chicken farm. So you need the land, you're converting it with some stills, some coverage on the top, and then you put a chicken farm, poultry farm. So that is land use. That is a rural development activity. Same thing, you have a land or a forested area, you clear it a little bit and put a school in there, and that becomes a land use. There is a land cover which was initially a crop or a forested land, you convert it to a school. Same thing, there are barren lands or crop lands, you put roads in between to enable better transportation, and that constitutes the transportation aspect. So all this, you have to put it in, which means this is supported by not other factors, but humans. So naturally, a school cannot come. Naturally, a forest can come. So that is the land cover. But you cannot have natural growing schools, croplands, etc. It has to be through the interference of humans. That is called land use. Let us look at an example of limiting land. For example, if you don't map it, suddenly what happens is the land available for rural development diminishes. Let's take this example of the Chennai Metropolitan Master Plan. And you could see that it is being proposed for 2026. A lot of land extensions have been happening, but a lot of this is still under the rural, peri-rural areas. And the people living there also want to be attached to Chennai because of the Chennai's branding. It's a city, it's a metropolitan. A lot of good aspects come like metros, trains, connectivity, airports, water supply, drainage supply, power supply. All these are based on Chennai's city network plan. So eventually a lot of the urban areas or the regions around the Chennai border would like to become Chennai. And so this was the master plan where it looks as from 2021 to 26, how it's going to change. And you could see that if, for example, all these were initially some pockets where we can zoom in to see. So mostly it is CMA boundary, taluk boundary, village boundary. So there are some villages, and then you have not many agricultural lands, but it is only reserved forest. Coastal regulation zones. There are some army and other regions also. So you do have some pockets of villages and boundaries, but what happens here is these villages were normally on the edges of the city, and now they are converting to city land. So there is a conversion of the land use, land cover to urban, and so rural entity is gone. When rural entity is gone, the water supply for irrigation, crop management, fertilizer subsidies, everything goes away. So there's a lot of livelihoods that is left, the land becomes a city land where the taxes could be high. So leave the administrative part. What I'm trying to get at is, if the lands are taken and converted to urbanization, then there's more stress on the rural environments to produce food, crop and water requirements for the cities. What is the difference in the land use and land cover? Land cover indicates a physical land type such as forest, open water, etc. Whereas land use documents how people are using the land. The physical appearance, the physical attributes of the land could be different, a forest, an open water body, etc. But if you're putting land use on top of the water body, let's say recreation, let's say fishing activities, or you have water theme parks, so that is a land use. For example, a recreational land use could occur in a forest. You can have a forest which is natural, but if you put boundaries and then say you have tiger walks, tiger safaris in jeeps, then that is a land use. Shrubland, grassland, or manicured lawns. So you have a naturally growing lawn. If you go to the outskirts of the city, you'll see just grasses growing. So that is land cover. But when you manage the crop, manage the grass in your house garden, that is land use. Sometimes it is difficult to differentiate it, right? For example, the forest. It could be a man-made forest. It could be a natural forest. When you say natural, how old it should be. So all these questions come, and this is a time-specific image. When I say land cover, for which year you should ask. So same thing we asked here, master plan for 2026. So there is a time-bound information in these data. So you should always put it as a time-bound information. And because of the time boundness, there is also a land use associated with land cover. So both are merged together and called as land use, land cover. It is one term. You will find it, just Google it as land use, land cover for India, for your district, Tiruchirappalli district, Tamil Nadu state, South India, all you will get data. The next aspect is LULC change. So land use, land cover is a one time snap. For a particular time snap, what is the land cover and land use? Land use, land cover change is how that changes with respect to another time. Let's say current, and I want to do pre-independence. So 1940s, what was the land use, land cover? And then 2023, March, what is the land use, land cover? We can compare and then show graphs of increase in agriculture or decrease in agriculture, definitely increase in urbanized land, etc. We'll do all these exercises in the hands-on tutorial. So now you know that what is the difference between land use, land cover, and it is a timestamp data. What you also have to remember is that the classification and the legend always is tricky. So how do you classify land? What does green refer to in a satellite image? Or what is crop? What is forest? What type of forest? Is it deciduous, evergreen? Is it needle, pine, all these things? So we found out that there is no global rule, which means a particular land use, land type is not the same in Finland as the same in India. However, some general classification exists, very general. The UN's kind of scheme is there, the FAO scheme is there, SNA, etc. So the worry comes here is there one specific for India? And there's not. So to discuss in live class, I would always throw this question and ask, is it needed? It is needed because only when there is a uniform classification of land across India, then the management schemes can come. Then the transportation schemes can come. Schools, livelihoods, libraries, all these can be given to a particular land use, land cover. And if the land use, land cover differs between states, then we don't have any normal baseline value to work on. Okay. So India is very fortunate to have diversity, but there are some things that has to be normalized. And this is one thing I feel definitely the classification of land use, land cover has to be normalized across India. What do you mean by crop? What do you mean by forest land? What do you mean by forest buffer, the riparian zone? What do you mean by coastal regulation zone? all these have to be one rule across the country, one classification across the country. What is the key in classification? We also need to avoid overlaps in the legends. So how are these classifications made? So the more important note here is each government agency will do different classification. For example, there's Central Water Commission. They will take the land along the rivers as floodplains, but that will be marked as alluvial fans in agricultural land. You see how the same land has different classifications with different agencies. Then how do you bring them together in one database? We cannot. Luckily, you can bring them all together in one database in a GIS when you start with the GIS layer. So for example, I start with the GIS layer or a satellite image, remote sensing, and then I put the boundaries of the Central Water Commission. I put the boundaries of the Agricultural Department. I put the boundaries of the Forest Conservation, Green Tribunal, etc. Then there is a match. Then you know that the same piece of land is being labeled differently by different agencies, which is a big concern. Why should the same land be differently labeled? Maybe for some aspects, for administration purposes, it's fine. When the rule comes, when the law comes, it is needed to have one basic land use land cover classification. Let's look at the basic principles and rules that is needed for basic LU and LC classification according to FAO. When you say the grid, inside the grid, if I say forest, the total area of the land need not be full of forest, but majority of the land has to be forest. Should cover the total area of the land that needs to be classified, irrespective of the fact it's being used for any specific activity. So for example, the same forest can house an army training, rock climbing, etc., etc. But if the granularity, if the resolution is small enough to capture just that, we can put it. Or we'll have to fully classify it as forest land and put a point inside to say that there is some military training camp. It should not overlap. There should not be multiple land use land covers for a single land, as I gave the example. It should cover all activities that are present. It has to have detailed information. What do you mean by, for example, I say it is a military base camp, forested military base camp. Then it should tell that there is part of the land which is forest. There's a part of the land which is under the army training. There's a conservation forest. For example, in IIT Bombay, we have a conservation forest on top, the Sanjay Gandhi forest. So all these have to be labeled and they should be covering all activities. The classification should not be confused with legends. Legends are that entire group. The classify is how you classify the land use land cover. All these should be linked to the policy recommendations and policy works. Again, all we want to do is to manage the land properly, better management, better leading to rural development, for which there are a lot of policies, and the policies should know what is forest. Let's say the very basic land use land cover. Let's say there's a forest and agroforest. If the policy does not have the term agroforest, then how can you label a land and then link it to policy? Right? So there is always a need to link all the database to the policy so that it can be applied for the land. As I've been striving across this lecture series, there's a need for better data, and the better data will come from satellites. There's a need for high resolution spatial and temporal. We'll go through some exercises in the ISRO database, and you'll find that why I'm pushing for the need for better data. And to understand better LULC terms that are used. The multiple terms that are used, we will be looking at what does it mean in real terms. Let's take an example here. This is the decadal LULC map of India. On the left-hand side, you see the land cover. It's just basically what is on top of the land. There is barren land, built up cropland, deciduous forest, evergreen forest. These are land cover. But in the right-hand side, you see, so this is the land use. You don't see the forest here. There's no overlap. So for example, all these are forests, but you don't see forest here. Because in that district, what is the land use has been mapped. So in that district, pulses grow in the medial range. What grows high in this range is other cereals, rice, yes, so Wembanad, Kutanad, all these are very high rice producing regions, Kollam, etc. You know that Chhattisgarh has a lot of rice, Odisha has a lot of rice. All these are showing that rice is very important cultivation in this land. So these are the differences between land cover on this side, on the left, and then land use on the right. We'll see more of this in the upcoming lecture series. Thank you.